All right, so I hope everybody can see that. If you can't, just come up to the front. You know, some of you said on your info sheets that you're reserved. I'll get that out of you. It'll be gone by the end of the semester. Everybody's going to get to know everybody else. So move up if you can't see. So what I've done here is I've screenshot one of the Webassign problems, number 7 off of the first Webassign, which was originally due 126. This particular problem will appear on the next quiz, but I'll summarize that in what's going to be on the quiz. And the question is, assume that the terminal side of the angle of t radians passes through the given point on the unit circle, and it asks you to find sine t, cosine t, and tangent t. And it gives you this point. So I just labeled out x equals 1 over square root of 17 and y equals minus 4 over square root of 17, because that's the x and y value. And what I know is that the x-coordinate is always the cosine and the y-coordinate is always the sine. The reason is they told me this is on a unit circle. We're going to do an experiment with a unit circle on Monday's class. We do in-class assignments on, we usually do them today, but since we had the quiz, I don't want to do more of that today. So on Monday, I'll give you an experiment where you're actually playing around with a unit circle, and you can actually see that the x-coordinate is always going to be the cosine and the y-coordinate is always the sine. That's what you just did on that unit circle. You took some particular points out of there, and you notice that the x-coordinate is always the cosine and the y-coordinate is always the sine. So I just wrote this again, that the cosine of the angle is the x-coordinate, cosine t equals 1 over square root of 17, and the sine of the angle is the y-coordinate. It's like a trick question. Keep in mind this little here, this little of t. So one of the first things your predecessors did last semester is they left out that argument, that of t. None of you guys are going to do that because it doesn't make sense. You have to have cosine of something. You have to have cosine of an angle. So that of t needs to be there. And it'll be on the rubric too. Forgot the of t business. You'll know when you're reading through to go put it back there. The tangent is the sine divided by the cosine. So the tangent is going to be the sine value divided by the cosine value. Doesn't that look pretty? What do I do when I have a fraction over a fraction? I invert the denominator and multiply. You can practice saying that to yourself over and over. If you take a bus here, you might get a seat free. Mumble it over to yourself. What do you do when you have fraction over fraction? I invert the denominator and multiply. Get some extra space around you. And notice that those square root of 17s disappear because they get canceled out, and you get negative 4. On Webassign, some of you were playing on Webassign and you were stressed out because you couldn't find the pi on the palette that you're supposed to put in, or using the capital pi. This is why I don't take it for grade. It doesn't work for me. I'm heavily criticized for not doing that, by the way, but it doesn't work for me. I don't feel like students are learning when they're doing that. But I like that it gives you the instant feedback and that you can see the answer and that you can do the practice it and go to the book. I love that part. So I assign the Webassign, but I don't take it for grade.
So you're not going to grade our homeworks?
No.
We don't have a homework grade?
You don't have a homework grade. But I can look in there and see what you did, right?
We get like extra points?
No, I can give you the correlations from last semester, who got A's and how much homework they did. There's a direct connection between the two. And who got F's and how much homework they did. You can see that connection. That's all that matters, right? Are you going to get an A or are you going to get an F? Believe me, you don't want Webassign for grade. You don't want it for grade. It's annoying, and there's something about it where students feel like they have to work on it the night before. Nothing ever works the night before. You can't submit anything. It crashes, whatever it does. It's a pain in the butt for me. It's a pain in the butt for you. But used in this way as a feedback tool so you know what the answers are going to be, you can look at a practice it problem. In that way, it's a good piece of technology. So that's how we're going to use it. I prefer it to the book assignment because you actually can see things.
So you invert the second one?
Yeah, invert the denominator and multiply. And I think I said it, right? Right up there, I say, somebody told me, don't walk around and point your fingers. See, invert the denominator and multiply? I say it right there. It's always that way. Remember, you're supposed to mumble that. Especially if you want someone to go away. What's your number? Invert the denominator, multiply. Invert the denominator, multiply. Don't go away. It's why I was alone for a long part of my life. Number 8 is a little bit different. It's a similar problem, but it's a little bit different than the first one. It's not on a unit circle. So assume here that the terminal side is blah, blah, blah. Same thing, except they don't have that unit circle business. 2 words left out changes the problem. You still have an x-coordinate and a y-coordinate. The x-coordinate is 0.7 and the y-coordinate is negative 0.6. Was it someone in here that says I shouldn't point at the screen, I should use a director in here? Because it's driving me crazy. I like want to walk around. I need to burn off my energy. I think it was in the night class. So here you go. X and Y are written out. Step 1 is to draw the triangle. To draw the triangle, the first thing is you have to plot that terminal point. So that X is 0.7. That means you go across on the x-axis. You walk a distance of 0.7. And the elevator goes down negative 0.6. Down it goes. And you plot that point. So that's the first part of getting the triangle. Second part is to make a line, a ray, that goes out from the center to that terminal point. And the angle they're talking about is the angle that's made by going down like so. Make sense? That's what they're looking for. So that's step 1. And on your rubric, it'll say, drew triangle correctly. First thing. Second is to put the lengths on the triangle. Notice that the elevator going down, even though it's a length, I put negative 0.6. You'll see why in a second. I need that negative value. It's actually going to make a difference. Step 2 is to find what we call the hypotenuse of that triangle. Right? So this is not the triangle there's an interesting little experiment they did with little kids, and I think they did it also with high schoolers. Well, they'll show people different triangles, but little kids will always say that an equilateral triangle is a triangle. But if you give them a right triangle or this triangle over here, they'll say that's not a triangle. Because they're used to always seeing the equilateral, that's the shape that they see, right? That's the one that they see. So just like that, you've always seen the right triangle like that, with the line going up. That's always the way you see it in high school, right? Well, here we've got an upside down right triangle. It's like flipped over the other way. So it's flipped over the other way, but my right angle is right over here, and the hypotenuse is going to be the longest side. So I'm looking for, see where my arrow is right here? I'm looking for this side right here. Do you remember how to do that? Say it again? Easier way than that. How do you get the hypotenuse? Hypotenuse. What's your a squared? What's your a? Leg squared plus leg squared, right? Leg squared plus leg squared. You've got 2 legs there. You got 0.7 and negative 0.6. So I put the negative in there because everyone last semester, even though I dropped the negative, it doesn't matter, right? Because I'm going to square it. They put the negative in there. But guess what they did? A lot of them put the minus outside of the square, and that changes the answer. And sometimes it gave them a negative under the square root. And then they got all twisted around and got the whole problem wrong. So just a warning bell over there that make sure that that negative is inside the square. Because what happens when you square a negative? It goes away, right? Scare it. It's gone. And so I get around 0.92 as my hypotenuse. Remember my cell phone policy, by the way. Just reminding you. Beep, beep, beep. My cell phone's out. I know that green light that buzzes over there. I know that there's a message for me. I just can't resist. So I got my hypotenuse. There it is, 0.92. Cosine is adjacent over hypotenuse. So I'm teaching you, I'm not giving you all the definitions and then doing the problem. I'm giving you the definitions inside the problems. So I have a little bit of a different style than what you might be used to. So adjacent is that guy over there, this length over here. Adjacent's this 0.7. Hypotenuse, I just figured out, 0.92. So cosine of t is 0.7 over 0.92. It's approximately 0.76. I'm going to guess that on Webassign, they'll want exact answers with the square roots. I don't care about it for you guys. So how do you check your work? Do it with the decimals, and then take the square roots of their answer that they give you on Webassign and see if they match up. Step 4, sine is opposite over hypotenuse. Opposite is this guy over here, and that's where the minus sign matters. The minus sign is going to give you a negative 0.65 when you do opposite over hypotenuse. And so you're going to get a negative number, so it matters. And it should be negative, right? Down here in this region, right down here, the y values, elevators are going down, and the x values are positive. So your cosine should be positive and your sine should be negative. So that absolutely makes sense. Step 5 is tangent. You can either do opposite over adjacent or sine over cosine. It doesn't matter how you do it. You can do the sine over cosine, you'll get the same answer. And I get minus 0.86. Any questions?
On a quiz, if you give us the months or whatever in degrees, you want us to, in like a radical form, do you want us to keep the answer in radical?
It'll say on there. It'll say on there, and I will tell you in advance. So I just told you on this problem, I do not care, right? So if you want to give it to me with radicals, more power to you. If you want to give it to me with decimals, more power to you too. So I'll warn you in advance. Remember the no surprises thing? Why should there be a surprise in math? Shouldn't be a surprise in math, right? Math is so straightforward and everything's got a little procedure assigned to it. I'm not into surprises, except if my husband's giving me one on Valentine's Day, I'm into that. But other than that, no surprises.